Hey guys, we are going to be doing surface area again today. So just like what you've already done this week, except for now instead of doing prisms and cylinders, we're going to do pyramids and cones. Okay, so this will require a different formula than the other two. But again, we're just following a formula like you have the past few days. Remember, guys, I really can't tell. Usually people do pretty well with this, but I don't really know when I'm not in front of you if you're having trouble with it or not. Nobody is joining me on my Zoom conferences. I would be happy to work out homework problems for you. So if you feel overwhelmed by today's notes for any reason, or you just have trouble on the homework, just join me at 2:30 on a Zoom conference, and we can take, 10-15 minutes to go through a couple problems, and then you can be on your way. Okay, so first we're just going to define a pyramid. Okay, so a pyramid is a polyhedron, that's just like a three-dimensional shape, in which one face, the base, can be any polygon. So, for example, in this pyramid, our base is a hexagon. In this pyramid, our base is a square. And then all of the other faces are called lateral faces. And we talked about those with prisms as well. Lateral faces. Okay, so that's all of these triangles that make up the sides. Each one of those triangles is called a lateral face. Okay, and you'll notice that those triangles each meet at a common point. That's like the vertex of the pyramid. Okay, we also have what's called an altitude. An altitude is basically a height, okay? So the altitude is a perpendicular segment that starts up at the vertex and then goes to the base. So this dotted line right through the center there, that is your altitude. Okay, the length of the altitude is the height of the pyramid. So we're just saying altitude, height, same thing. Okay, we can use those words interchangeably. Okay. What is the word I'm looking for here? A regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. All of the pyramids that we're looking at today are going to be regular pyramids, meaning their bases are regular. Okay, so if this side is 6, all the sides are 6. Okay, it's a square. It's not a rectangle, it's a square. It's regular. Okay, and then same thing up here. The hexagon is a regular hexagon. That also means that all of these triangles are the same. Okay. We also have something called a slant height. Okay, the slant height, which we abbreviate with an L for some reason, is the length of the altitude of a lateral face, or the length of the height of a lateral face. So remember, these triangles are our lateral faces. The height of that triangle, so this right here, is our slant height. That's our L. Okay? So it's really exactly what it sounds like. It's the height of the slant. Okay? So this triangle is slanted. The height of that triangle, we call that the slant height. Okay. Now, you can figure out the formula for surface area by taking a pyramid and kind of like cutting it open and laying it flat. This is called a net. It's like taking a three-dimensional shape, kind of like I did with that box. So here's like a box that I can open up and lay it out flat. It's called a net. Okay, I can do the same thing with a pyramid. So this is kind of a picture of it laying out flat. And we know that if we want to find surface area. We would have to add up the triangle plus the triangle plus the triangle plus the triangle plus the square. And then that would give us our surface area. Okay? If we just do all of the lateral faces and we don't do the base, we call that the lateral area. Okay? So how would I find the lateral area here? I would add up my 4 triangles. How do you find the area of a triangle? You do 1/2 base times height. So 1/2 the base, which is called S because it's a side length, okay? And then times the height, which we're calling slant height because remember, the height of that triangle, we call that the slant height of the pyramid. So we would do 1/2 base times height or 1/2 S times L, okay? And then we would multiply that by 4 because there are 4 triangles. So this is how you find the area of all of the triangles added together, or the lateral area, okay? And then we're just going to rearrange those terms. So we move the 1/2 out front, we put the 4 and the S together. Parker, can you be more, jeez, I swear, people don't understand what I'm doing around here. Okay, sorry about that. Okay, that's really unbelievable. Okay, so we rearranged our terms here, and then 4S, so a side length times 4, is really just the perimeter around the pyramid, okay? So 4S, we're changing that to P for perimeter. So 1/2 PL is how you find your lateral area. And then if you want to find the entire surface area, you just take that lateral area, okay, and you add on the area of the base. So this is our surface area formula. 1/2 PL plus B. And remember that capital B is area of the base. So just like before, P is for perimeter. Okay, just like before, capital B is area of the base. Okay, and then L is our slant height. Okay, so we're going to try this out. We're going to find the surface area of both of these pyramids. So first thing I'll do is I'll write down my formula. And I forgot my 1/2 there. There we go. Okay, and then I'll fill in what I can. So 1/2 here, and then the perimeter is going to be the distance around the shape. Okay, remember, all of the pyramids we're looking at today are regular pyramids. So if I have 5 on this side, I have 5 on this side, and 5 on this side, and 5 on this side. It's a square pyramid. So my perimeter is 5 plus 5 plus 5 plus 5, or 20. Okay, the slant height, it's already right there for us. That slant height is 6. And then we have to find the area of the base. Okay, our base is this square. How do you find the area of a square? Length times width, or base times height. So we'll take length 5 times width 5. So 5 times 5. Okay, so half of 20 is 10. 10 times 6 is 60. And then 5 times 5 is 25. Okay, so 85 meters squared. All right, we're going to do the same thing over here, same formula. Did you guys like that peek at my marital bliss here? I swear, I'm sure you guys are dealing with the same stuff at home too, like people not respecting what you're trying to do, people making noise when you're trying to do your work, all that kind of stuff. I'm sure we're all in the same boat with that. Okay, so perimeter. Let's go ahead and plug that in. Our perimeter is going to be 6 times the 6 sides of the hexagon. So 6 plus 6 plus 6 plus 6 plus 6 plus 6. Okay, or 36 inches. Okay, the slant height is already there for us. It is 9 inches. Okay, now for capital B, we need to plug in the area of the base, the area of that hexagon. And remember, to find the area of a hexagon, we're going to find the area of one right triangle. Okay, we're going to find the area of that right triangle, and we're going to multiply it by 12, because I can fit 12 of these right triangles inside my hexagon. 2 on this side, and then 2 more on every other side. So 12 total. So we're going to take this, and we're going to take 360 divided by 12, and we get 30 degrees. So this is a 30, 60, 90 triangle. Okay, we know that this is 6. That means this will be 3. And they actually already helped us out here. This is 3 square root 3. So they could have just given us this, and we could have figured this out because it's a 30, 60, 90 triangle. But they were nice, and they gave us both of them. So we don't really have to do any work here. We can just take 12 times the area of this triangle. Okay, so that's, to find the area of a triangle, we always do 1/2 the base of the triangle times the height of the triangle. Okay, so this is your capital B. Okay, that's the area of your hexagon. It's the area of the triangle times 12 triangles. So that gives us the area of the hexagon. And now we can just simplify from there. So I'm going to, in my calculator, I'm going to go 0.5 times 36 times 9, and I get 27. Okay, and then over here I'm going to do 12 times 0.5 times 3 times 3, and I get 54. And then there's a square root 3 with it. Okay, I couldn't fit my units in there, but this was inches and inches, so this would be inches squared. And then that is my exact answer. I can't add those together because this one has a square root 3 and this one does not. So this is as simplified as I can get. So this is my exact answer. And then I can figure out what that is approximately. Okay, I can go 27 plus 54 square root 3. I missed my 7, didn't I? Okay, there we go. 27 plus 54 square root 3. And we get approximately 120.5 inches squared. That is your approximate answer. Okay, let's flip over to the next page. Okay, so here it says, what is the lateral area and surface area for the following? So I'm just going to start with surface area because that's the formula that you're always going to have like written down for you. And then we'll talk about what the lateral area would be after that. Basically, this part's the lateral area. All of it together is the surface area. Okay, so let's fill in what we know. Our perimeter is going to be 30 plus 30 plus 30 plus 30, or 120 meters. Now, the slant height is this right here, and they did not give that to us, so we're going to have to figure that out. Here's how we can figure that out. You can see there's kind of like a shaded in triangle here. That's a right triangle. Okay, I know the bottom of this right triangle is 15. Now, how do I know that that's 15? I know that that's 15 because the entire side length is 30. So if I start at the center and go to the edge, that's going to be half of 30, right? All the way across is 30. So halfway across is 15. And if I know two sides of a triangle, I can figure out the third side by doing the Pythagorean theorem. So I'm going to do that really quick. I'm going to go leg squared plus leg squared equals our hypotenuse squared. And I called that L because it's the slant height. Okay, so 36.4 squared is okay, and then 15 squared is 225, and then I'm going to add those together, and I get 1,549.96 is equal to L squared, and if I take the square root of both sides, I see that L is the square root of 1549.96. Now, that's not a pretty number, okay, but it works, okay? That's what we're going to use. If I take the square root of it, it's going to be a decimal that runs off my calculator, so I'm just going to leave it right like this. That is my slant height. I will plug that in for my slant height. okay? And then remember for capital B, we find the area of the base. Our base is a square. Finding the area of a square is very easy. Length times width, or base times height. Okay, length times width is 30 times 30. Okay, all right. So I'm going to simplify this so that says 60 square root 1,549.96. This is meters, so it'll be meters squared. And then 30 times 30 is 900 meters squared. This is your surface area. Okay? It is approximately 3,262.2. Okay? Now, if they asked you to find lateral area and surface area. So I found surface area already. What is the lateral area? The lateral area, again, is just this first part. It's this. This is your lateral area. It's not adding on the base. So your lateral area is that, which you could say is approximately 2,362.2. There we go. Okay, moving on to cone. Cones have a new formula. Okay, here is our surface area formula. And remember, if we want to find lateral area is just the first part. It's not adding on the base. Okay, so here's the lateral area. R is for radius. H is for height. Okay, if they give you that. It's not part of the formula though. And then L is still slant height. Okay, so let's start with number 1. Surface area equals pi RL plus pi R squared. So our radius is 15. Our slant height is 25. Okay, again, radius is 15. Okay, so I plugged everything into my formula. That was super easy. And now I just multiply these together. So 15 times 25 is 375. I'm going to put a pi next to it. Centimeters times centimeters is centimeters squared. Okay, and then 15 squared is 225. I'm going to put a pi next to it, and then centimeters squared. And then I can add those together. Those are like terms. 375 pi plus 225 pi is 600 pi. That is my exact answer, and that is approximately actually it's this 1,885.0. Okay, and moving on to the next one. It actually says leave in terms of pi, so we can actually just leave it like that. We don't even need the approximate answer. Okay, and then number 2, we're going to write down our surface area formula again. Okay, our diameter is 4, so all the way across is 4. That means our radius from center out to the edge would be 2. So radius is 2 feet. Now, they did not give us the slant height this time. They gave us the height instead. So they gave us height. We need slant height. Okay? We know how to solve right triangles. We know this is 2. We know this is 5. We can find L. Okay, again, this 5 is pointing over here. So I'm just going to scribble it out at this point so it doesn't distract me. So this was 5, this is 2, I can find L. Do the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Okay, that's 25 plus 4 equals L squared, or 29 equals L squared. And then take the square root of both sides. On the right side, you get L. On the left, it doesn't come out nicely, so we just leave it as the square root of 29. So our slant height is the square root of 29. Okay, and then radius I just plugged in 2 again, because our radius is 2. There's really nothing we can do here. I'm just going to rearrange it. So I'm going to write 2 square root 29 pi. 2 square root 29 pi. And then my units are feet times feet, so feet squared. Plus, over here, 2 squared is 4. I'll put pi next to it, and then feet squared. Now, both of these have pi, but I still can't add them together because this one has a square root 29 and this one does not. So they are not like terms. They don't have the same square roots. So this is as simplified as you can get. This is your final answer if we're going to leave our answer in terms of pi. Okay, so that's it for the notes today. Again, if you feel like you have questions or if you feel like you need help on the homework, just log on to the Zoom meeting at 2:30. And if that time doesn't work for you and you still need help, just reach out and we'll figure out another time. Okay, guys, thanks.